All right, so we move on to part two now, and this is one of my favorite SpongeBob episodes where they're both fighting for Squidward's attention and drinking water, and then all of a sudden they get to this stage. And so let's talk about obesity, right? So I start off with some, just interesting pictures. This is in your slides as well. Again, more of the epidemiology, some informatics stuff on where we would, on where the risk would be, on where we're going to target people. Obviously, we have a number of individuals who BMI wise are classified as obese, medical issues, health, medical costs. Here's our groups, our populations that have high risk. Pretty much everybody, I mean, except for one group, right? So there's a pretty big fall off here. These are all in the same kind of categories or areas of rank. Here's our ages and other kind of stuff like there. So you can kind of see a little bit more. This is where you would target, a prevention program. So these are our at-risk populations. We use our informatics to make decisions on healthcare stuff. All right, so we talk body composition, and the common one is to do a two-compartment system where you got fat versus non-fat. All right, and so you just do a simple, there's fat versus everything else. And so if it's not fat, it's lean body mass. And so that's not only just your muscle, but it's the bones, it's the cartilage, it's all that other stuff that's basically not fat. And so you can kind of see some guidelines here. The NATA position statement has a couple of other guidelines on, just healthy body percent fat that should be. So you should be, men, this is the range, women, this is the range, and the minimum number, right? We have to have a certain number. I think it is appropriate to mention that, and we've talked about this before, that muscle, right? 5 pounds of muscle is smaller, but weighs the same as all this fat. So basically muscle weighs more than fat does as we go through there. Oops, I cut off the thing. Sorry about that. The body mass index is, we've talked a little bit about that using height and weight. It's very, very common, very, very easy to do that. And it's not the best, right? There are some drawbacks, but we do know that disease risk, right? So when we talk about risk for disease, people in these higher areas of BMI have a much higher chance or much higher incidence of having pretty significant chronic diseases. And so either osteoarthritis or some of the metabolic diseases, those kind of stuff. So whereas it's not the best for the athletic population, I'll see that, but it is a decent for your general group population that to kind of gauge who are the at-risk folks in that population. So we have this here. This is I showed this last time. I think I even posted this last time. You can look on that and kind of give you an idea of how BMI works. So I'm going to stop this real quick. I want to see if I can get that back. Yes, there it is. See, now that was bothering me. So now I can see it. All right. Anyway, so body mass index, these are the numbers you have to know, right? So you have to know your underweights. You have to know this is the over 25 means you're basically overweight, right? And so that's when the health risk starts to increase, and then over 30 is obese. Now there's a over 35 being morbidly obese, so there's a higher level, your extreme obesity, and only America we do something, we do it right? We got to go to the ends, the extremes. There's the height weight chart, right? The BMI. There's other ways to assess body composition. You can get really fancy with this DEXA, and it's basically an X-ray and kind of is able to measure specifically the density of what's in your body. So it's very quick, but finding one of these machines, getting one of these machines to obviously it costs some money, so there's an expense to that as well. Hydrostatic weighing is one of the more validated. DEXA is probably the most accurate, but hydrostatic weighing is pretty darn quick or accurate as well. And really, it's based on, this is what I need you to know. It's based on this theory that fat is more buoyant than the lean tissue. So you put somebody in water, you take the weight away from them, and what you do is, what this person's going to do is they're going to blow out as much air as they possibly can, blow out all their air, go underwater, and then we measure them here. We compare that to on land, and then we can run some formulas and do that kind of stuff. And I'll there. That's what it kind of looks like. Is the person you gotta sit in this chair. You don't make too many waves or bounciness, because we want the scale to be set to get a good measurement. But yeah, you're sitting under there for about 2-3 seconds with no air in your lungs. Yeah, so it's kind of freaky the first time you do it, but it can be done. Other ways, there's these bod pods where you do kind of air displacement. You measure the volume before, how much volume is in this little compartment, and then you get in, and then how much have you displaced, kind of stuff. Again, the validity becomes, a lot of these techniques now, we start talking about, is it really that valid? And we start to compare, we compare it to our gold standard of either the DEXA or hydrostatic weighing. Is kind of that's how we measure, are these valid. Skin fold thickness tends to do pretty decent, right? So there's a you take skin fold measurements. You just take the subcutaneous fat, you pinch it, you kind of measure it. You'll take an average, like, so we would measure this little triceps fold 3 times, take the average, and then you measure at 3 other sites. You come up with you add those up, you come up with a formula, and you can kind of get a decent amount of a decent idea or estimate of what the body fat percentage really is. And so really the calculation is already done for you. There's a number of charts that you can look at. And so based on whatever your number is here, you look it up on a chart, and it tells you, oh, it's 25%. Okay, good. So very easy to do. You should have an idea. There are different caliper sites or pinch sites for males versus females. I do want you to know this part right here. Go back. I do want you to know this part, that the theory behind this is that subcutaneous fat, the amount of subcutaneous fat that's just right under our skin, there is a proportion. So if we know that, then proportion wise, we can kind of calculate the fat throughout the rest of the body. So there's the different skin fold thickness sites where you're gonna kind of measure those. And again, you would do this 3 times, take an average of this, and it comes out in little millimeters, that kind of stuff. You're trying to pull out just the skin. We're not trying to take a big old chunk and pinch the fat. We're trying to just pinch, and you can see on both these, we're just pinching this superficial layer of skin as we go. All right, the girth measurements are another one that we can do, and it's typically measured around the hips for females, and around the abdomen for males. That goes into some of the different body shapes that we're going to talk about here in just a bit. And so the final one is this bioelectric impedance. You send electrical current through somebody, and you measure it going out, and you measure it going through, back coming in. So basically, we send it through the foot here, it goes up through the body, it comes back to here. This thing measures it. How much, fat's not a good conductor, so how much actual electricity gets back to the circuit when you complete the circuit. So again, the validity of all these ones past hydrostatic weighing becomes a little bit in question, except for skin folds. Skin folds tend to be, at least a little bit better. Here's that circumference part. I probably should have put this in when I was talking about doing the girth measurements, but when we do waist circumference, it just kind of gives us the different ways that men and women carry their weight. Not every woman's going to carry their weight in their hips. Not every man's going to carry their weight in the belly. But for the most part, it's kind of like BMI. It's a good risk analysis that when we have these kind of body shapes, we look at, all right, when this right here, when this is the primary mode of fat storage, there is a much higher disease risk. Doesn't mean it is. When this is the primary form of fat storage, which is gynoid obesity, then the disease risk is not as high. So this is the much more healthy pattern as opposed to the belly fat, which is bad. So that's why we're doing that. This is a pretty good assessment of risk, and so I put you that, if you can take a waist circumference, combine it with the BMI, it gives you a pretty good assessment of what the risk is to some of the chronic diseases, definitely cardiovascular disease, and some of the other ones. All right, so I'm going to stop this one here. Talked long enough, so there you go. Don't be or actually don't be careful, right? Don't be messing around on this bike path. This is Danger City.